All right, and welcome back. So today we are going to be starting chapter 5, which is all about systems of equations. So what it means to be a system of equations is essentially it's just two equations that are happening at the same time. Previously, we've talked about linear equations, linear inequalities, we talked about functions, and then most recently, linear functions and how to graph them, right? We have slope-intercept form, standard form, and we can graph linear functions on a graph. Well, a system of equations is just two of those happening at the same time. And all we're going to try to see is, do we have a shared coordinate point on that graph after we graph our two linear equations? So let's have out our guided notes. Let's start out with talking about a solution to a system, and then let's talk about how to actually solve a system. So again, have out your guided notes. Let's begin. So previously, we've checked to see if an ordered pair works as a solution of an equation. But now we're going to check to see if an ordered pair is a solution to a system of equations. So what we're going to be doing is we're going to be telling whether or not 1 comma 9 is a solution of this system. X plus y equals 10 and 3x plus y equals 12. These two equations are happening, quote unquote, at the same time, which is why they call it a system. They're simultaneous. We're going to be doing them at the same time. So just like we would before, we're going to substitute 1 comma 9 into now one of these equations. Just a reminder that x is going to be 1 and y is going to be 9. So we're going to substitute it in. We have x plus y equals 10. We have 1 plus 9 equals 10, and that is true. This checks out. It could be a solution to the system so far because it works for one of the equations. But in order for a coordinate point, an ordered pair, or just general values to be a solution to a system, it has to work for both equations. It so far works for the first equation, which is great, but now we have to verify that it works for 3x plus y equals 12. So we're going to substitute it in. We're going to end up with 3 times 1 plus 9 is 12, and we end up with 12 is equal to 12, which is fantastic, which means that the ordered pair makes both equations true. So the given coordinate point, the given ordered pair 1 comma 9 is a solution to this entire system. So it has to work for both equations. It cannot just work for one. It has to work for both. Now on the right-hand side of our guided notes, we were asked to tell whether 2 comma negative 3 is a solution of this system. Let me transfer this over, that way it's not as visually confusing. So again, we're going to substitute 2 comma negative 3 into both of the equations. Let's choose the first one. We have x plus y equals 5, which means 2 comma negative 3 is equal to 5, and we know that's not true. We know that negative 1 is not equal to 5. So we can stop. We're done. There's no need to check the other equation. The ordered pair is not a solution to the system because it's not a solution to all of the equations within our system. So again, in order for a solution to be a solution to the system, it has to be true for both equations. We cannot pick and choose. Awesome. With this, maybe. There we go. Please work on problems 1 through 4 on the guided notes and resume when you're ready to move on. All right, so now we're on the back side of our guided notes, and we want a graph to check if 5 comma 7 is a solution to this system. Y equals x plus 2 and y equals 2x plus 3. So we can solve these systems by graphing. And if it's not the solution, we're going to find it. So let's look at the graph in which these systems form. Let me see if I can highlight a bit for you. That way it can make it a little bit easier. All right, so y equals x plus 2. That is going to be this line right here. So we graphed that yellow line. And then we're like, all right, we have a system, which means we have multiple points, or multiple lines, I should say, pardon me. we have multiple lines, which means that I'm going to graph that second line now. So let's say y equals 2x plus 3 is the blue line. This is going to be our blue line. So we need to see, hey, where does our yellow and our blue make green? Well, my lines were a bit too thick here. Let me see if I can go back and try out a different size line for you. That way we might be able to see a better green here. Oh, that's much better. So we have that thin yellow line. Thank you for bearing with me here. We have this thin blue line, and we want to see, hey, where does it make green? Well, it makes green at the coordinate point -1, 1, because our lines overlap. They intersect. So the solution to this system is not going to be 5, 7. It's going to be -1, 1. And we call that point the point of intersection. Let's jot that down real quick before we move on. We're going to call that the point of intersection. Let's do that in green. So right here, we call that the point of intersection. And a smiley face, because why not? So when these two lines overlap, these two lines intersect, that's going to be the solution. So our solution is -1, 1. And again, we call that point where they intersect, very creatively, the point of intersection. So whenever we graph a system of equations, what we're really looking for is that point of intersection. And we can check whether coordinate points are solutions to our system by simply substituting them in, or we can graph them on a graph. Awesome, great job. With this in mind, please work on, oh no. With this in mind, please work on problems 5 through 8 on the guided notes. Thank you for your patience during those technical issues, and thank you for enduring that awkwardness towards the end. Thank you very much for checking in. Keep making yourself proud. Please let me know if you have any questions, and I'll talk to you soon.